Well, good morning, everybody. Well, thank you for coming. And before we start, I asked Tom to please provide us in a prayer, and we'll go from there. Thank you, Tom. Good morning once again. I'm Scott Van Ornum. I'm pleased to be here today. It's an honor and privilege to talk to you a little bit about what, as a scientist and educator and a whole other bunch of things, I guess, what analogies have strengthened my faith, perhaps, and that's kind of a little bit of what my presentation is. Unlikely title that you've perhaps ever heard about before, but as I do before every lecture and class and presentation, I just pray and hope for the best, so we'll go. If it's any questions you have along the way, just feel free to interrupt me, and we'll go from there. What we're going to head off today is take a look at a little bit of religion and science. There's a polarization between it, and certainly we've all been blessed to be in these sessions the past few months here, and I think you've all agreed that it seems like one or the other is always at odds with one another, but we'll look at that a little bit. A little bit of organic chemistry introduction. As an educator, if you give me a platform, I'm going to teach, so we're going to give you a little bit of tutorial about what organic chemistry is, namely the notion of what chirality is. It's just a simple concept that I think will make sense. Then we'll go into what's called the Miller-Urey experiment. We've had a lot of teachings on evolution as well. I know in the last few months a little bit of that. And we'll see how that experiment back in the 50s, sort of even to this day, becomes important and people still hinge upon it, even though that it has so many misgivings and really not even a viable theory these days. Lastly, pharmaceuticals and natural products. I was a chemist in industry for a long time. I'll tell you why those experiences have really strengthened my faith, along with the natural products, as I call God's processes. These are compounds in nature that we extract. You've heard of natural products, maybe. Some could be anti-cancer drugs, things like that. And then we'll wrap up with some conclusions. Well, I think some of the thoughts in the scientific community, from what I've seen, is probably, it slides a little bit, but 40% of the Americans, scientists, believe in God. Now, whether they fully admit it or not is the next question, but that's probably about what it tends to believe. Really, the public believes the scientific sector. I remember hearing somebody mention this earlier this year, that if you think that there's experts and you go with that, right? They are experts in this field, we'll take what they say as law. Well, that's not always the case, because there's a lot of biased reasoning in the way that people want their results perhaps to be slanted in the best possible form. So peer pressure to conform, well, there's a big peer pressure out there, whether it's in the science community or just among friends. But we don't necessarily conform when we don't need to. And scientists will really rely on other disciplines as well. You get an expert in biology, that person knows what they're talking about. Whatever they say, well, it must be true. Not always the case. I don't think that's necessarily true, and that's certainly not going to find its way into getting money. If you're applying for grants, well, and you throw any religious concept into a grant for funding with National Science Foundation, it's game over. It's hard enough getting money these days just in general, but science, at least in the government proposals and others, are not going to allow for any type of theological advancements when it's related to getting money. And I think scientists are supposed to park their faith at the door. Yeah, well, that's fine. I've never done that. There's been a lot of situations that I've been in a precarious situation, and I've prayed big time when I had $100,000 worth of chemicals in a reactor, and it was, I thought, going south. Oh, what can you do? So it was an interesting experience, but it worked out okay. But at the same time, these are faith-strengthening things for me. I think the current attitude is, on the science side, you can see what we have to deal with: experimentation, come up with some observations, deductions, and it's supposed to be God-independent, whereas religion could be, some people think about as being, of course, a faith issue: myth, culture, self-delusion. Okay? So there's a polarization there a little bit. In 1998, just before I wrapped up at my graduate studies at UWM, Milwaukee here, I saw this at the Kohl's in Thiensville. It's no longer there, but I'm like, wow, this is an interesting article, Science Finds God. So I'm like, yeah, I have some time now. I'm done with grad school. I'm going to go out and have a job, so I had a little bit more time. I'm like, I was always interested in science and theological ramifications, and I bought this and I read it intuitively, and what they had was a lot of heavy-hitting name scientists, if you will. Charles Towns, he got the Nobel Prize for the laser back in the early 60s. So I'm like, I emailed him, we'll see what happens. And he wrote me back. He since has just passed away recently, but I think my email was something along the lines of, what does it for you? What do you think is your bottom line reason for the universe, the existence, faith? And this is what he kind of wrote back to me. He says, my sense of presence is difficult to describe, but somewhat similar to my sense that I have free will. I can go down to the second paragraph. I sense a presence in the beauties of nature, the structure of the universe, and in the behavior and history of humans, including his own. So I think he sensed that something was bigger and grander. Now, I think he subscribed to evolution. I don't know. I've read a lot of articles with him, but I had that sense. But I think he was a Christian in the end. Leon Lederman, on the other hand, another Nobel Prize physicist, wrote him. He wrote me back, so that was nice, but he's like, bang, right? I'm a convinced believer in evolution. Okay? He goes on to say about all the nucleosynthesis of background radiation and things like that, all the classical physics arguments that would support what he believes in, and that the universe was created 13 billion years ago in a cosmic explosion, right? I.e. the Big Bang, which I guess it really didn't make a bang, it was more like a swoosh maybe, but that's if it happened, right? So in any case, he is clearly in line with the mainstream. Michael Behe came out with this book called Darwin's Black Box, if you've ever heard of it. He's an interesting fellow. I actually called and talked to him on the phone, and just to say, well, his argument with this book, and it's a pretty good book. The basic idea with the Darwin's Black Box is, his analogy is a mousetrap. If you take the platform away, it's no longer a mousetrap. It doesn't work. You take the mechanism away, it's no longer a mousetrap. There's only a few parts to a mousetrap, and if you take one of those away, it doesn't work. So his idea is kind of refuting evolution, more like intelligent design, that God, of course, created us. We're all there. We have all the innards to be working at one time. So, of course, there's been a lot of arguments against his analogy, and that's kind of what you have. He's actually a professor at Lehigh University, and if you go to the department website, they categorically say, well, down below, the faculty is unequivocally supporting of the evolutionary theory, but they make this sort of disclaimer that while we support and understand that he has his own views, but they're his own views only. So they sort of try to cover themselves, and because at the end there, I tried to bold it, although it may not show up, the last sentence, it is our collective position that intelligent design has no basis in science because it can't be tested experimentally. So they try to allow them to teach there, but they have their little disclaimer that covers it. John Polkinghorne, wasn't able to email him, but he calls himself the vegetarian butcher. He was a physicist for many years, really well respected, and now is a pastor over somewhere in the UK. So he tries to meld the two. He would be more of a theistic evolutionist, though. He tries to bridge the gap or allow both to come into play, but he's just another player that was actually part of that article. In my trade magazine, you'll see stuff like this, evolutionary advertising. Well, for whatever reason, this company thinks that their building blocks accelerate evolution. So these are, of course, things that you see out in mainstream media quite a bit. I think this probably rings true, these after-Eden things, is that no matter what happens, okay, show me a sign, zap, I am the Lord thy God. The person says, wow, a natural phenomenon can spell. No matter what the proof may be, whether it's biblical, whether it's your own intellect, some people will not simply believe in or nor have faith, and that's really sort of a travesty, not having the faith or even being exposed to it. But in any case, how I got to where I'm at now, UWM is up in the corner there, clockwise, Abbott Laboratories. I worked there for 4 years, working at the bench, doing chemistry on small scale, and then taking it to 2,000-gallon reactors and trying to make chemistry on large scale. Was there for 4 years. On the lower left is Cedarburg Pharmaceuticals. They're actually in Grafton. Was there for about 8 years, and now currently I'm at Concordia. I'm as close as I can get to the lake, and I'm at home. That's it. That's my last stop, I hope. So, beautiful experience. So what is organic chemistry? I think we all can come away with some ideas. Of course, it's living organisms, have the chemicals embedded in them. Petroleum, plastics, drugs, things like that. I like organic because it's conceptual, and we'll see that as we go through the talk. Acetic acid, made up of vinegar. A lot of times you put that on your salad. Propane, we fire up the grill with propane. Ethanol, of course, the beverage industry and other fuels. And acetone are common organic molecules that you come away with. As you know, there's nothing you really haven't touched today that's not probably organic. Right. Who's used ibuprofen? I took 2 tablets this morning, so I am coursing ibuprofen through my body. No other reason than to, not to demonstrate the drug, but anyways, you know it as an anti-pain reliever. We draw the things like this, carbon, hydrogens, bonds. The simplest notion is down below. And you might have seen these even on commercials these days. You'll see these organic structures in your pharmaceutical pamphlets. You'll see those, things like that. But that is the structure of ibuprofen, and that'll lay the basis of the talk a little bit later. Some other molecules, Lipitor, familiar with Lipitor? A good friend of mine is the one that put that chemistry on the market, at least developing the chemistry, because they make tons of this stuff a year. You might expect. It's $1 billion drug, was for Pfizer. And there's just some other ones there as well. Well, what is not organic chemistry? In 2010, when I first got on campus, Student Life approved this thing that I found its way in the bulletin board. Organic has sometimes a stigmatism for being conceptual, comprehensive, a lot of stuff to memorize, and a lot of work. Well, that's true, but I was hoping that they wouldn't necessarily, right off the bat, say it caused more dropouts than OCHEM, pre-law, and calculus combined. All right? The idea is that it's hard, yeah, but it doesn't lead you to drinking, I don't think. But they could have at least put organic chemistry third. That would have been nice. Nor is it the big ball chasing you. Although I think at times my students say, yeah, it feels like that. Organic is more starting with a snowball, and then as each section advances in learning, you use what you learned in chapter 1 at the very end of the course as well. It's a building upon things. But there's memes out there. We've seen this before. It's too bad that it really has a stigmatism of that nature, but in any case, studying does help, by the way. So here's where I got the Indiana Jones and Organic Chemistry Facebook site about 4 years ago. I felt that, okay, as a way of melding with students, since they're usually have some electronic device with them, maybe I can create a site that I can post stuff online to follow me from a personal aspect, from a little bit of a faith aspect, and we kind of see what happens from there. We've got about 300 followers. I'm put in my place, though. We have a comfort dog called Zoe at CUW. She's got 3,000 followers, 10 times as more as I do. But in any case, I usually bring Zoe to before exams. That way, if they see the comfort dog walk in before the exam, they know, oh, this might not be a good day. But it breaks the ice. The students really like to see the dog, and she does a very good job. Well, I have to remind myself that if my students are 19, 20 years old, they might not know who Indiana Jones is these days. Perhaps they know that guy, and I don't know anything about Harry Potter, other than it's apparently good. I know a little bit, John, not much. But nonetheless, maybe I have a Harry Potter site, but that would be a whole different game, and I have enough going on right now. But in any case, most of them have seen the movies. Since they had one a few years back, I take my hobbies a little bit seriously, or I devised a Indiana Jones and Passion of the Christ lower level in my home, and I figured tell my students, if you don't have a life-size doll, then you haven't taken your hobby to completion. Got a nice little, it's my office, a nice little resurrection scene going on there, so I like to find some inspiration there. The gear that you need, no, they don't go out and buy hats and whips and things like that, but the textbook, of course. Models, we play with models. I have them develop what I call the reaction grail diary. When you're studying this stuff, make a little grail diary that you can refer to, and try to find ways that they can at least tackle the stuff. My syllabus, I don't have quizzes, they're called quests. My exams are adventures. The final is called the Last Crusade, things like that. So, exploration digs, little things like that. It works. So on the site, I'll post stuff like this. So instead of Indy grabbing the fertility idol, it might be a concept from the textbook, a figure. Then I'll have a little blurb about it. Have a drink on a blimp. They're studying, father and son are studying a little bit of that. So you get kind of the idea. A light reaction, don't so much look at the graphic, but you get the point. It's just kind of interlacing chemistry ideas with the movies, and I guess they study from this site. Usually what I'll do is I'll post stuff that finds itself on exams, and after the fact, oh, I remember seeing that. Well, yeah, it was out there. Harrison Ford, I think, had organic chemistry, because this is sometimes the way my students look when they're taking the exams. But this was in Oshkosh. We got to see him, but nonetheless. Well, Faith at Learning is big at Concordia. There's our mission statement there. We try to help students develop in mind, body, and spirit. And that's not so much a challenge given what we have at Concordia as far as all the facilities and things, but it's trying to interlace faith with organic chemistry. And you just can't present a slide, and, oh, this is a reaction, and then jump into some biblical aspect that doesn't connect. And that I find as being the big challenge, is trying to do that with the students. As most of them there are for the education as well as the Christian environment. I think they're both there. There are some students strictly there for the program. That's it. Not so much the faith, but that's okay. We try to show them both aspects of what we have going on. Glory to God, I think that's probably the one thing I learned from one student, that try to do everything with that mindset. He got a 99 on one of my exams, and I normally congratulate the person that gets the highest just with a quick email, and that's exactly what he said, was to be glory to God. I mean, he didn't take any accolades. His dad is a Wells pastor, so that probably he's been taught very well, but I've had some nice discussions with that gentleman, and he's now in pharmacy school, but that was a very nice thing to learn. So here's our little lesson for today, is the notion of chirality. What is it? Okay, that's just a term. What really it involves is, say, for instance, take your hands, for instance. Okay, you can't superimpose those, can you? Okay, there's just, of course, no way. That makes sense. Well, molecules can exist like this too, where if you look at that carbon, the C, that has 4 different groups attached to it. Okay, and you can have 2. These are going to be called enantiomers. Let's just go to the next slide here. This is lactic acid. Okay. The whole idea is to realize that they are the plus and the minus. Okay. They're mirror images of one another. Okay. They have the same number of carbons, oxygens, hydrogens. Okay. But you could not take a model of the 2 and superimpose those. Okay. No matter what you do, unless you take off the bonds and make them superimposable. So they're different. Even though they look the same, they're mirror images, they have different properties associated with them. Okay. And that makes a difference. Back to ibuprofen. So it's sold as what's called a racemic mixture. So the chiral center is, I don't think the laser pointer works, but you kind of see it right there. That's the chiral center. That's the carbon that has 4 different groups. A hydrogen, this is called a methyl group. This is another group, we'll say, and this is the other group. All right. This is the other chiral center. That's the only difference in the molecules. Well, the S ibuprofen on the right, that's the one that does the job in your body, that relieves pain. Okay? The R does nothing. It's benign. But they sell it as a 50-50 mixture of the 2. Okay? Because it's okay for the R to be benign. Okay? And from a cost point of view, you would not want to just purify and make S exclusively. It's too expensive. So companies will just say, all right, the 50-50 mixture is good. What the body does, however, is interesting. The R on the left, there's an enzyme in the body that actually converts that chiral center to the S. And then that makes it more bioavailable for pain relief. So that is incredible when you think about just the fact that there's that type of a feature in the body. Now, how that mechanism came to be, I mean, that's beyond the scope of this, let alone no way can we subscribe it to evolution. There's just no way. So nonetheless, that's kind of an interesting feature. One chiral center makes a difference, as I said. Thalidomide on the left, if it's the enantiomer that is in the S form, that's right here. That's the only difference between the 2. Of course, there's the mirror. This has birth defects. That's a sedative. So not quite life and death, but there is some compounds that subtle difference can be the difference between something that works in the body and something that's actually very, very bad. So I call that sort of God's way of 3-dimensional stereochemistry, that something that subtle makes a huge difference. Anybody hear of Taxol? Taxol has been around for quite a while. It's an anti-cancer drug. This has 11 chiral centers. Okay. They all have those little stars next to them. So there's 11 different chiral centers. You could change one of them, okay, and that will give a different effect. Okay. It might still act as an anti-cancer, but not as good as actual Taxol itself. Well, there's 11 of them and 11 chiral centers in that molecule, and the expression down below shows that when you raise 2 to the 11th power, there's a potential of 2,048 actual different, what we call isomers of Taxol. That's a lot. Okay? It would take a while to draw all those out, to say the least. But the point is that those 11 chirals are fixed. That's what actually does the anti-cancer drug for therapeutic effects. I had somebody in my audience when I gave this talk last year at Concordia that his wife was on Taxol, and that it was impressive that it's worked out so well for her. At Cedarburg Pharmaceuticals in Grafton, I managed this project when we were selling this for another company. It was difficult to make, to say the least, and we'll see it towards the end. The basic idea is this. The key fits into what's called a receptor. When it fits nicely, the drug works. On the right, you see sort of another generalized version of the drug fitting into a lock and key type portfolio. All right? And if there's a little bit of a chirality off, it's not going to fit into there as efficiently as it should. Therefore, the drug's not as receptive to doing the job that it's designed to do. All right? Well, amino acids are something that we're all aware of in one form or another. So the building blocks of life, okay, there's 21 amino acids in nature. They all have a certain chiral center. They're all chiral. They all have that carbon that has 4 different groups. And we won't, it's just to show you the gamut of them from here for this next discussion. Well, back to 1953, Miller and Urey came up with an experiment that, as I mentioned earlier, still rings in today as being proof of perhaps evolution or chemical evolution processes. Urey was the director, the mentor. Stanley Miller was the graduate student in 1953, so we know who did all the work. But nonetheless, the basic apparatus was this. They envisioned trying to simulate some type of early Earth chemical evolution type process. So what they designed was the apparatus you can see on the left is, I think, one of the original ones. On the right is more of a schematic. So they had sort of what they believed to be an early atmosphere. They pumped in ammonia. What else we got? Methane, hydrogen, yeah, real conducive to life, water, things like that. They've put an electrode in there to simulate lightning, as if there's some spark that needed to get this chemical reaction going. All right. But the bottom line is they designed an apparatus with intelligence behind it. They really slightly skewed the way that they wanted things to go. But it's okay. That's worthwhile to try and see what happens. Right? 1953, chemistry was just starting to be probably mainstreamed into being that. But suffice to say, and I have a slide here that sort of shows that it's not a good situation. This is a textbook in biochemistry, a very well-known one. It still talks about this particular experiment as being the potential for showing that chemical evolution under relatively mild conditions is feasible. Okay? It's not really. Okay? It's unfortunate that you still see a lot of this stuff out there. Okay? And if it's in a textbook, it's law, right? Not so much. All right? Depends on who's writing it. But these are the assumptions of the experiment. They assumed this early Earth, now this is excluding biblical perspective, of course, but they were assuming that there was a reducing atmosphere, so there was no oxygen in their apparatus. There was, as I said, the apparatus was specifically designed to actually capture organic molecules. So when they sparked and made this really brown sludge is what it amounted to be, of course there's just many tons of compounds in there. They had to have some way of capturing them so they could analyze them. Well, there wasn't that type of apparatus available. And there's the lightning that I mentioned it. They did many modifications to the experiment. So many that they actually were able to show that they made more amino acids. Well, of course, you start figuring out, well, experiment 1, oh, there's only a few, well, let's do this. Oh, there's more. Well, what are you doing? You're driving your experiment based on trying to get the optimum result. All right, but interesting. So this table just shows you kind of the mix of stuff that's came out of the mixture. We'll say formic acid is an organic acid, lactic acid, acetic acid, a bunch of acids. They actually made more stuff that's detrimental to anything ever being viable for producing life. Sure, they did make some amino acids. Okay, some amino acids did form, but the trouble was that they made amino acids that this amino acid is conducive for life. They made the mirror image that is not. So they actually made the gamut of everything that could be made. All right. It's no different than just entropy at work, okay, random chemical reactions producing just random compounds. But I'll say that it was an interesting experiment, at least from the point of, okay, they're trying in 1953. That was a unique experiment to say, let's see if this is any validity to it. Of course, this is what is currently accepted today as far as how, okay, we got here, however you want to call it, right? It is really randomness at its best, if you're going to go that route. This is really what organic chemistry is. It's organic reactions. The black tar rock star is what I sort of call it. A lot of times, the dreaded black tar is what you get in organic chemistry. You run a reaction, you work it up, and then you're left with something that looks on the left. Okay? That's not good. Usually you have garbage in there. Okay? These are under, of course, controlled situations, chemical reactions that intuitively have been designed to work. So they don't work always in 100%. So going from something like that to, of course, something as complex as humans just doesn't necessarily ring. Okay? It's almost impossible that I think that is there. That certainly lends itself in the biblical view. This is much more simpler, makes more sense in my mind, based on all the reactions that I've trashed over the years, and there's a lot of them under what I thought was intelligent design, but sometimes not so much. Let's talk a little bit about, in this last 15 minutes or so, some of the drugs that I made that also has strengthened my faith, realizing that in order to make these drugs, it's hard. Chemistry is not easy, and that is going back to the idea that evolution has its shortcomings as well. But there's just some features about how to get a drug to market. Very difficult to do, takes a long time, a lot of money, and a lot of know-how to get it. Lipitor, for example, took many, many years to get on the market. These are a couple of the compounds that I've made. Travatan is an ophthalmic drug. If anybody's ever used it, it's just for glaucoma and things like that. That's currently on the market. I was involved with an anti-cancer drug, exemestane. That's also on the market right now, helping people out. We did try to make synthetic marijuana, THC. It has its therapeutic purposes. It is actually sold right now as what's called Marinol, but it was a very difficult project to purify the product at the end. We had $1 million invested in it, and we couldn't make it work, so that fell by the wayside. When I was at Abbott, I worked on this compound for 4 years. It was a 9-step synthesis, so I was on steps 6, 7, and 8. I took maybe 100 grams of stuff and eventually took it out to 2,000-gallon reactors with 500 kilogram charges, so that was interesting chemistry. They had $500 million of research in this compound, and then Abbott just dropped it. All that work and effort. They sold it, I think, to another company, but it hasn't made the market. And down below is another drug that I'm working on, or had worked on with Cornell University. It's for quick surgical procedures. It paralyzes the body within minutes so that doctors can get the endotracheal tube down the throat, and then after a few minutes, you come back out of it. So that has a lot of interesting work. I say synthetic organic chemistry intelligently driven most of the time. Right? So again, I can only attribute it to largely get a faith in your chemical reaction. There's the small scale approach, and those are my master's students. You can see we have a nice little 5-liter reaction, but then when it was at Abbott, we had something like that, where we would charge stuff into chemical reactions. So a lot can go wrong. It's just not saying, oh, I did this on 10 grams, I'm going to scale it up to 100 kilograms. You just can't take the multiplier. There's so many things that can go wrong when you simply try to take the chemistry up there, and that just shows how hard it is. But this is the one thing you can count, is that whatever will go wrong, or whatever can go wrong, will go wrong. Can't even get it out right, but we've all experienced that, Murphy's Law, whatever you want to call it, and that's something that you can't control. I like this statement: by faith we understand that the universe was formed at God's command, so that what is seen was not made out of what was visible. That sort of rings into, well, how do I know that I made ibuprofen, or ibuprofen is what it is? I can't see the carbon atoms. I've been doing chemistry for 25 years. I can't see it. It would be nice to see it. I make these molecules, and I get to play with plastic pieces. And that's okay. Really, that's what we have. But we have instrumentation that when you take what's called an IR here, or a proton image here, collectively you have all those pieces of information that point to what the structure should be. And that's how we do that. But it really is a faith issue. We have faith in the instrumentation, we have faith in God's processes to make it, and that's what has helped us out. Here's what I call God's process: natural products found out in marine life, plants, wherever really. And a lot of these species could have some type of therapeutic effects. You'll see a lot of journal articles that will talk about, well, they extracted this from a plant, and then their research lab went in the lab, and a lot of graduate students made the actual compound. Okay? Might take a long time, as you'll see with Taxol. So this is the structure of Taxol again. Remember, it had 11 chiral centers. Okay? And it comes from, I think on the next slide maybe, 1962 was discovered, again, anti-ovarian cancer, from the yew tree. So it's harvested from the yew tree. From bark this, to actually get commercial quantities took 31 years. And you might imagine how many chemists and people were associated with that. A 140-foot tree can yield, after you harvest it and purify and get it to a point where it's saleable, half a gram of Taxol. Okay? That's not very economical, nor can you do that. What they do now is they have an advanced, it's called the English yew tree. Okay? It's a tree that has an advanced intermediate in the synthesis of Taxol. So they literally have farms of this stuff, and they harvest the yew tree, the English yew tree, and then that comes in the lab, it gets processed, and then there's a two-step synthesis to make the drug. Much more effective and much easier to do. Otherwise, the cost would be just astronomical, to say the least. So Taxol was a hot target, as you might expect. It had its therapeutic advance, so the race was on for numerous research groups to make it. Okay, can you make it? Well, then can you scale it up economically so that it isn't $1 million per kilogram or something like that? Although it could be, in my day, Taxol, a kilo of it, which is about 2.2 pounds, so a couple pounds. They were probably selling it for about $120,000 to $140,000 per kilogram. Right. That's the bulk drug, we call it. It goes for formulation. In this case, it was, I believe, an injectable. But so I go back to those chiral centers, those 11 chiral centers. It took 30 research teams, literally thousands of chemists, probably hundreds of PhD degrees were obtained with just Taxol itself, working in teams. So one group would synthesize, say, one ring, another group would synthesize another piece, and they kind of put it together that way. Okay. But as I say at the end, and that probably is the bottom line, nature performed this with ease. Right? We all kind of know who did that, right? Because that's really kind of where it's at. Well, we could have future synthetic targets. I suppose organic chemistry allows itself to make ET maybe. That would be kind of neat. Nano people on the right, that was actually been made by a group and published. They call them nano people. And they had all these various little molecules that you could make from them, and there's a whole gamut there. Packers, well, we'll see how they do this season without anybody. This was a synthetic target that it's not been made before. And clearly you can see the nuance with it, of course. Simple, which is good. Okay, we like the simplistic nature of it. Very hard to make. Okay, chemically, it's just no way, because there's that symmetry element to it. When you start to try to put things together, a lot of side reactions can happen. But this would not be, as I said, a trivial molecule to make. But if you can make it and then publish that, I'd be always interested to see how the editors and how the scientific community would actually publish that. Would they leave it the way it is, realizing what it really stands for, the symbolism of it, or would they turn it to their side and skirt the issue with it? But that remains to be seen, perhaps down the road. Some conclusions. I teach in the pharmacy department as well. You walk into the building, they have this particular Proverbs, which is really nice. Trust in the Lord with all your heart and lean not on your own understanding. Acknowledge him, and he shall direct your paths. And I think that's always a good way to start your day, to realize, okay, we all have our academics. That's what I try to tell students. You gotta have fun. Okay, in the end, yeah, study, have fun, don't worry about GPA. Learn, apply, and that's one facet, but of course there's the religion component. Try to apply what you've learned there as well. Family, I got a couple, just a shot here that it's been an interesting ride this summer, but Mom and Dad's 55th wedding anniversary was on Thursday, so I congratulate them on that. Mom's been visited by pastor. My mom has dementia, and she's been doing okay. But I don't know, Pastor, Tom, the next slide might have a video. When I click it, you might have to, we'll see if it works. But in any case, she's not as verbal these days, but let's see if you can click that on or not. I'll leave her with the last word.
What's it say?
What's it say?
God is good all the time. Yeah, that's right, isn't it?
That's right. God is good all the time. That's one of the few last things that she says, but I think there's a few more words left in her, so that's always been a plus. With that, I thank you, and appreciate your time, and hopefully there was a little bit of my background and how this strengthens my view of my faith. Thank you very much. Thank you.